In this lecture, we're going to explore how shared pointers work with arrays. And here is a simple example of how we can do that. The syntax we use to set up an array of objects using shared pointers, and the array is going to be dynamically allocated from the heap as you see here. The syntax is what you see here. So we say std shared pointer, we specify the type, and then we say that it is an array using these square brackets here. And then we give our shared pointer a name, and we allocate our array on the heap using the new operator. Once we do this, we're going to create an array containing however many elements we want, and then we're going to put the elements to initialize our array. This is something you can do. And if you don't specify all the elements, the remaining elements are going to be auto-filled using default constructors. They are going to be default 0 initialized. And for example, for the integers here, the remaining elements are going to be auto-filled with zeros. For non-fundamental objects like dog, we're going to call the default constructor and we're going to fill in all of those elements here. And this is the syntax. Once we have the array set up, we can loop through the array and do all kinds of crazy things. For example, we can print out all the elements here. We're going to print each element in our shared pointer int array. As you see here, we're going to print each element at each index. We can print the array containing our dog. We're going to be printing the name of each dog in our array. We can really do all kinds of crazy things. For example, down here, we can even set elements. We can grab the third element in the first int array and change that to 28. We can change the dog at index 1 in the second array here and change that to be a dog named Fuzzy, as you see here, and this is going to work. One thing you should know is that support for shared pointers with arrays was added in C++ 17. So if you are on an older version of C++, this is not going to work. It is most probably going to give you a compiler error, so you should be aware of this. Another thing you should know is that make shared is not supported with arrays. If you try to do this, you're going to get a compiler error on most compilers. Some compilers do offer some partial support for this, but it is really not stable across compilers. And if you happen to be writing C++ code that is going to be consumed by different compilers, this is just going to be a nightmare for you. So I wouldn't really recommend this. And I am not going to talk about this anymore. But one thing you should know is that you won't need to use row arrays with smart pointers that much in practice anyway, so this is not a big deal, but you need to be aware of this. In later chapters of the course, we're going to learn about collection types that we can use, and they are going to make arrays almost useless because you're not going to be using row arrays in a practical daily C++ development that much anyway. So this is not a big deal, but I want you to be aware of this. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is shared pointers with arrays. We are going to grab our template files pretty quick. We're going to copy them, not cut them out. And we're going to put them in place. Another thing we're going to do is steal the dog class from a previous lecture. We're going to copy it and put that in our current project. And then we're going to open this up in Visual Studio Code by dragging and dropping here. This is going to open our files up. We have dog, cpp, and main. Let's open up dog.h. And then we're going to hit main and include our memory header because we're going to be using smart pointers. And we're going to put in our dog class. And we're going to clean up because we don't need this clutter here. The first thing we're going to do is to set up a pair of arrays. One is going to be an array of int. Another is going to be an array of dog objects. But we're going to be managing these arrays through shared pointers. And the syntax we use is what you see here. We say std shared pointer. We specify the type. We say that it is an array using square brackets here. We say the variable name, and then we allocate space for our array on the heap using the new operator. Once we do this, we're going to have our array, and we can really do whatever we want with it. But before we try and print the data in our arrays, we're going to change what we have in the first int array. And I want to prove to you that the elements that are not filled in with data are going to be default initialized. For fundamental types, for example, the int, we're going to put a 0 in. That's going to be our default value. For custom types, we are just going to call the default constructor and default initialize the other elements that we didn't initialize here. So this is something you should know. We specified that we have an array of 10 dogs. We just put in 2 dogs. The remaining 8 dogs are going to be default initialized. The same is true for our int array. We specified that we have 10 elements, but we just put in 8 elements. The remaining 2 elements are going to be default initialized, and they are going to be initialized to 0. And we can see that if we print the elements in our array here, we're just going to loop 10 times, printing the element at each iteration, and we're going to see these guys printed out once we run this in Visual Studio Code here. Let's do this. We're going to build with GCC. The build should be good as you see here. We're going to clear. We are going to bring up a terminal and we're going to run this. We're going to clear and run Rooster. Let's go up and see what we have in the output here. We're going to see our int array. It's going to have 10 elements in from 1 all the way to 8. This is what we specified in our code here, but notice that the remaining 2 elements are initialized to 0, so they should be default initialized. And for fundamental types like int, that's going to be initialized to a 0 version of the type that we have here, and that happens to be 0. For custom types, we see that we have 2 dog objects. One is dog1, the other is dog2, which we specified here. But the remaining dogs are going to be default initialized. And if we go in our dog class, we're going to see that if we don't initialize our dog, the name we're going to have in is Puffy, as you see here. This is what we provide as a default initializer for our string member variable here. So that's the data we see if we don't specify the name for the dog. And we're going to have 8 Puffy dogs, and this is what we have in our output here. The last thing you see is that we're going to call the destructors for our dogs once we hit the end of the main function, because then the shared pointers are going to go out of scope, and this is going to release the memory that was managed by these shared pointers, and that happens to be these arrays here. So for dog, we're going to see the destructors called for all the 10 dogs that we have in place here, and that's what we have in our output here. I hope this makes sense. Okay, so once we have these arrays set up, we can really do all kinds of crazy things. For example, we can set the data in. In this simple example, we're going to change the int at index 3 to 28, and we're going to change the dog at index 1 to be a dog named Fuzzy, and we are going to see this reflected in the output we get from our program here. We are going to build with GCC to be able to see this. The build is good. We're going to bring up our PowerShell window, and we're going to clear and run Rooster again. The dog one is going to change to Fuzzy. This is what you see here. And the int at index 3, 0, 1, 2, 3 is going to change to 28. And this is what we see here. And you can do this. Okay, so this is really all I had to share about using shared pointers with arrays. Again, remember that the make shared syntax isn't going to work with arrays. If you try to use this in any way in C++20, you're going to get compiler errors. And if you happen to need to use shared pointers with arrays, you will need to use the new operator as we have seen in this lecture. And after you have your shared pointer managing your arrays, you're not going to need to do any memory management. When the shared pointer goes out of scope, your memory is going to be released and everything is going to work as expected. This is really all I had to share in this lecture. I hope you found it interesting. In the next one, we're going to see how we can use shared pointers as function parameters and return values from function. Go ahead and finish up here and meet me there.